Okay, today I'd like to introduce a concept called a limit. But basically what I would like to tie in is how we have calculated a limit on our last homework already. Because what a limit is it's a value that you are approaching. And that's our whole big concept, of value we are approaching. So let's talk about how we've already done that. Okay, this blue graph here is a function. So it's y equals f of x. It's a function. This red line is a tangent line. Quick review, a tangent line is a line that touches the function at one point in an area, and only one point in that area, and does not cross the function, just touches it. And the slope of the tangent line is considered the instantaneous rate of change of the function. It's how steep the function is at that point. This second line is a secant line. The secant line goes through the function at one point, and then it goes through the function again at a second point. So from A to B, the secant line goes through the function. Now, this has a slope which you were calculating on your last homework assignment, and we can use the calculations of this secant line to estimate the slope of the tangent line. So let's see how we actually make that happen. So basically, I have a point here. This point is this A value, and it's the slope of the tangent line at A, is the output. So at this x value, the slope of the tangent line, you should be able to see it is a horizontal line. The slope should be at 0. Now, for the secant line, starts on A and goes through B. And to calculate the secant line, clearly, when I take B minus A y values over B minus A's x values, you will get the slope, which is negative. And here it is, negative. It's below the x-axis. So as my points get closer and closer, the slope of my secant line gets closer and closer to the slope of my tangent line. It's approaching the slope of the tangent line. So then I can say the limit must exist. That as I get closer and closer, I am approaching the limit, which is the same slope where the secant and the tangent, let's see if I can make it line up perfectly, and a little hard to do sometimes. There, it disappeared. So I no longer see 2 because they've become 1 when my point B is actually on point A. Here's the problem. I can't calculate a slope there because my B and A are the same. Let's take a look at what I'm talking about, a little bit more detail. Oops. Put that back. Close enough. And let me pull my distance away. There we go. Doesn't matter. Okay. So, got my 2 points. Let me zoom out so I can see them. Point B is over here. I'm just going to move it over here so I can see it a little easier. And I'm going to take a screenshot. Okay. So, let's see. I want to say this is my secant line. The slope of the secant line, and this is my tangent line, slope of the tangent line. In this case, we already said the slope of this tangent line happens to be 0. Now, here's point A, here's point B. In our last homework assignment, let's see, went too far down. The distance in the x direction from point A to point B we called h. And we talked about this notation. It's very important because this notation is what we're going to be using throughout calculus. So you got to get really comfortable with it. So I'm going to call this first point A, and it's the output at A is the y value. Instead of calling this point B, I'm going to say it is A, and then I went an additional h units over to get to B, and then the output at B is that. So my slope of my secant line then is going to be represented by this formula. The output at the second point minus the output at the first point over the distance we've traveled in the x direction, which we call h. And what I was saying before is as the points get closer and closer to each other, so as point B gets closer and closer to point A, I'm going to put this in green, h is getting smaller, which means h is approaching 0. Now, we can't use 0 because if we did, we're dividing by 0. Dividing by 0 is never allowed. So I can't use 0 to calculate the slope of my tangent. I can just get closer. But what we did on that homework was we said that the slope of the secant line was getting closer and closer and closer to the slope of the tangent line. So you might see something printed like this. As h goes to 0, the slope of the secant line becomes closer to the slope of the tangent line. This is the idea of a limit. So we're going to modify this to a slightly different way of representing that same statement. So I'm just rewriting it with now a little bit more formal notation. And again, so this whole statement, as x gets closer to 0, the slope of the secant line gets closer to the tangent line, will now be written this way. Okay, and just to actually not make it ambiguous, let me do something real quick here. Let me make this smaller. This is in subscript. So the limit of the slope of the secant line is the slope of the tangent line as h goes to 0. Again, it says the same thing. When I say the limit of the secant line is the tangent line, what I'm really translating is the slope of the secant line is becoming closer and closer and infinitely closer to the slope of the tangent line as long as the distance h between my 2 points gets smaller and smaller. So again, we have been calculating limits. Now, for the next video, I'm going to talk a little bit more about the formal definition of the notation and formal definition of the limit.